For the last couple of years, we've gotten pretty used to AIs that can talk, AIs that can write, and even create some pretty wild images. But what about an AI that can actually do things? Well, today we're diving into a blueprint for what might be the next generation of AI, agents that don't just respond to you, but actually take action. Let's get into it.
I mean, seriously, just imagine an AI that could not only plan a complex software update, but then go and execute the code, test it out, and even fix its own mistakes, all inside a real live environment. This is a massive leap from the chatbots we know today, which are mostly just one-shot generators. We're talking about moving from simple conversation to actual creation.
The fancy term for this new frontier is agentic crafting. But really, all it means is teaching an AI to handle complex, multi-step jobs. It's not about getting a single perfect answer on the first try. Instead, it's about a whole process of trial, of error, and of refinement, just like a human craftsman would do. Okay, but as you can probably guess, building these kinds of agents is a monumental task. And the research paper we're looking at today frames this challenge in a really, really interesting way. And this right here is the core metaphor. A truly powerful AI agent isn't some single brilliant model that you just invent overnight. No, it's an entire city, a whole ecosystem that you have to build from the ground up, piece by painful piece. So what makes this so incredibly difficult? Well, for starters, these agents have to tackle tasks with tons of steps, where you don't even know the final result until the very end. It's kind of like baking a cake, right? You don't know if it's a success until you pull it out of the oven, and that makes learning really tricky. But maybe even more important, these agents need a safe place to fail. I mean, you can't have a trainee AI accidentally deleting a production database. So it all boils down to this. You need to build the entire workshop before you can even start teaching the apprentice. And that's exactly what this research proposes. They call it the Agentic Learning Ecosystem, or ALE for short. It's a complete end-to-end system for building these action-oriented AIs. And this diagram, this brilliantly lays out the whole system. Think of this as the master blueprint for our entire city. See that loop in the middle? An instruction comes in, the agent acts within its environment, and the results are fed back into the system to make the agent smarter. This closed loop is literally the engine of the whole city. So let's break down each of those three big parts. Every city needs solid ground to build on, right? In this ecosystem, that's called rock. It's the secure, sandboxed environment where the agent can do its work safely. So think of rock as providing a whole series of perfect, safe, digital workbenches. These are totally isolated environments where the agent can practice tasks without any risk to the outside world. Rock's job is to manage how the agent interacts with these spaces, and most importantly, to contain any and all failures. Now, what's so cool about this slide is how it visualizes that idea of fault isolation. If one of the agent's practice runs crashes and burns, it doesn't bring down the entire training system. The other ones just keep on running, totally unaffected. This kind of stability is absolutely crucial when you're training at a massive scale. So, we've got our construction site. Now we need the training academy to actually teach our workers how to do stuff. So let's move on to Roll and see how this system builds our agent's intelligence. Now, Roll is this sophisticated reinforcement learning framework, but it really boils down to this simple, powerful loop. First is the rollout. That's where the agent tries to complete a task and it creates a log of all its actions. Then that entire attempt or trajectory gets a score based on how well it did. Finally, during the training phase, the agent's model is updated based on what worked and what didn't. You just repeat that millions of times and you get one very, very smart agent. Okay, so we've got the construction site and the training academy. The final piece of the puzzle is mission control, the interface that gives the agent its tasks and lets us interact with it. And that is iFlow CLI. iFlow is basically the bridge between a person's instructions and the agent's actions. It orchestrates the whole workflow, manages all that back and forth communication, and it provides the actual interface for a human to give the agent a job and see what happens. It's also where you can incorporate human feedback to make the agent even better over time. So, the city is built, the ecosystem is in place, and the result is an agent model they named Rome. But the real question is, how well does it actually perform? And here we can see how Rome stacks up against the competition on two really tough benchmarks. On the left, you've got a test for using command line tools, and on the right is a benchmark that tasks the AI with solving real-world software engineering problems. In both of these charts, you can see Rome, highlighted in blue, performing incredibly well.
But let's just focus on this number right here. On the SW Bench Verified test, which measures the agent's ability to solve real-world issues from GitHub, the Roam agent achieved a pass rate of 57.4%. And that is just astonishing. What this result means is that Roam is not only outperforming models of a similar size, but it's even competing with these massive, massive models that have over 100 billion parameters. It just goes to show you the power of having a dedicated training ecosystem.
So let's zoom out for the big takeaway here, because this is about way more than just one powerful AI model.
The real breakthrough here isn't the Roam agent itself. It's the whole agentic learning ecosystem, the blueprint for Roam. What they've created is a repeatable, scalable, and robust way for pretty much anyone to build their own customized, high-performing agents for any number of tasks. And this quote from the paper just perfectly summarizes the whole shift in thinking. It's no longer enough to just have a bigger model or more data. The real challenge, and honestly the real opportunity, is to co-design the entire system, the training infrastructure, the sandboxed environments, and the evaluation protocols all working together in harmony. Which leaves us with a pretty fascinating final thought. If this is the blueprint for creating AI that can build and fix and create things in the real world, what kinds of amazing, complex, and maybe even world-changing things are we going to choose to build next?